Hello everyone, my name is Jalees Nehvi and I present our work titled Differentiable Event Stream Simulator for Non-Rigid 3D Tracking. Our goal here is to track non-rigid 3D objects using an event camera. Since tracking fast-moving and deforming objects using conventional cameras often results in motion blur and redundancy, we leverage the advantages offered by the event camera like high temporal resolution, low redundancy, and high dynamic range to perform non-rigid 3D tracking. Our idea is based on an analysis by synthesis approach, where we try to leverage computer graphics rendering with the event generation model and synthesize events such that they correlate with the events recorded by the event camera. According to this event generation model, an event is triggered if the difference between the current brightness and the previously stored brightness exceeds a certain threshold. Our pipeline is described in this figure. The method assumes a template in the form of a parametric model or a generic mesh, and we assume that the initial parameter state θt-1 is known. We then feed the models at both these states into the differentiable renderer, which renders a pair of images. We then take the difference of these images and threshold it according to that threshold function. We choose the following function as a suitable choice for the thresholding operation since it's differentiable and approximates the thresholding operation quite well. The output of the thresholding function is a generated event frame. We then pre-process the input data recorded by our event camera into a 2D image-like representation, which we call the event frame. We then feed both of these frames into an optimization framework where we minimize a given objective function to estimate the unknown parameters θt star. We show our results on real as well as synthetic data. First, we have the synthetic hand sequence. Next, we have the synthetic paper sequence. And finally, we have the synthetic ball sequence. We also perform quantitative comparisons given the ground truth. We can see that our method outperforms the other competing RGB-based methods. Next, we show our results on the rail sequences. First, we have the rail hand sequence. And finally, we have the rail paper sequence. So that's all. So thank you very much.